in today's video, we are going to talk about topic 9.7, related rates of change. If you look at your success workbook, it will be on page 211. Before we start with the subtopic, I would like to remind you that you will need to remember the formula for total surface area, the volume, the perimeter of this solid. The formula will not be given in your examination, but you are expected to know this because you might need to use this formula to answer questions. So remember volume and surface area for prism, cylinder, pyramid, cone and sphere. You can always Google. There's a lot of available formula sheets online. Okay, for today's topic, we are going to talk about related rate of change. Okay, rate of change. Kalau dalam bahasa Melayu adalah kadar perubahan. Okay, kadar perubahan. So rates of change. For example, the rate of change of area, say, will be denoted by the symbol dA over dt. Rate of change of volume, dV over dt. Rate of change of height, so dH over dt. So the phase rate of change is always represented by over dt. And what does it mean by rate of change? Suppose that we have example, rate of change of area dA over dt is equals to 10 centimeter squared per second, which means that the area of the object is increasing at the rate of 10 centimeter squared for every second. So it's going bigger and bigger and bigger and bigger in size. So if we have a rate of change, if the rate of change of something is greater than 0, means that the value is increasing. And if we have the rate of change is less than 0, means that the value is decreasing. If it's equals to 0, then there's no changes at all. Tak ada pembesaran, tak ada kehilangan. Okay, no changes. And for this subtopic, it's very important for you to recall the chain rule. Remember chain rule, if we want dA over dt, then we should have dA here times with dt here, and the thing here should equal to the thing here. So for example, if we have dr, then here should also be dr. That is the chain rule. Let's go straight to example question. Oops, sorry. So let me clear the page first. So this question is taken from your success workbook, self-access 9.7. I'm sorry because the picture is slightly darker. Let me zoom in so that we can see what the question says. The radius of a circular blot of ink. So we have a circular blot of ink is increasing at the rate of 1/6 millimeter per second. So the rate of change of radius is equals to 1/6 millimeter per second. So means that the radius is increasing at the rate of 1/6 millimeter for every second. It's getting bigger and bigger and bigger and bigger. Take note that if the question mentioned increasing, then the value of the rate should be positive. If it mentioned decreasing at the rate of 1/6 millimeter per second, then the value of dr over dt should equals to -6. But in this case, it is mentioned that it's not decreasing, it is increasing. Sorry, not -6, but -1/6. Just in case if the question mentioned that the rate is decreasing. Back to our question, it's not mentioning decreasing, it's mentioning the increasing. So we have the r over dt is equals to 1/6. And then find the rate of increase of area. So we want to find dA over dt, rate of change of area, when radius r equals to 12. So if we want dA over dt, according to the chain rule, this is just equals to dA times with something over dt. dA over something times with something over dt. And from the question, you can see that it is given dr over dt. So here we put dr, and if this here is dr, then here should be also be dr. Okay, as if we can cancel them. Okay. So we have the value of dr over dt, which is just 1/6. So just substitute the value. dA over dr times with 1/6. The problem now, we do not have dA over dr, but we can find dA over dr by finding A. Okay, for a circle, area of a circle is just pi r squared. Hence, dA over dr is just equal to 2 pi r. So take this value, insert here. Take this function and insert here. Okay, so you should have 2 pi r times with 1/6. And it is stated in the question that r is just 12. So we insert r with the value of r is 12. Just substitute the value of r, so we should get 2 pi times 12 times 1/6. So press your calculator. 12 times 2 is 24 divided by 6. So the final answer is 4 pi. And it's area, rate of change of area, so it should be in millimeter squared per second. Or you can write as s to the power of -1, which means that this should be your final answer. In illustration, we can see that if you have this circular blot, it will increase and it will increase and it will increase. The area will increase at area increase at the rate of 4 pi millimeter squared per second. Okay, that's what the question is all about. Okay, let's move to one more question. Let me clear the picture first. Okay. Alright, okay. Again, I apologize for the dark picture, so I'm going to zoom in so that we can read the question and extract all the information given. Okay, question number 5. An open cylinder has a radius of 20. So we have the open cylinder, which means that there is no cover top here. It's just empty top, no topless. Okay, and the radius of this cylinder is 20 centimeter. And obviously, this is the height. Okay. Water is poured into the cylinder at the rate of 40 centimeter cube per second. Water is poured inside means that we are dealing with volume. So dV over dt is just equals to 40 centimeter cube per second. So it means that you have water poured into the cylinder at the rate of 40 centimeter cube per second. It's the volume, rate of volume. Next, find the rate of increase of the height. So we want to find dH over dt. So if you want to find dH over dt, again, here should be dH by chain rule over something times something over dt. Since we have V here, so here should be dV, here should be dV. And we have the value of dV over dt, which is just 40. So dH over dV times 40. But we do not have dH over dV. But we can still find dH over dV by finding the formula for V, volume of the cylinder. Okay, volume of cylinder formula is V equals to pi r squared H. And it is given that R is always equals to 20. So it's just equals to pi 20 squared H, which is just equals to 400 pi H. So dV over dH is just equals to 400 pi, which means that dH over dV is equals to 1 over 400 pi. Since 400 pi is just 400 pi over 1. Why do we find this? Because the question wants us to find dH over dV, not dV over dH. So you just take this value and insert here. Okay, so which is equals to 1 over 400 pi times with 40, which is just equals to 40 over 400 pi. This is just equals to 1 over 10 pi. And now we can have a look at the unit. The H is centimeter and T is in, let's see, second. So we have one, so that the final answer dH over dt is just equals to 1 over 10 pi. H is in centimeter per second. So means that when you pour the water at the rate of 40 centimeter cube per second, the height of the water level will increase at the rate of 1/10 pi centimeter per second. Alright. So for your homework, I would like you to do self-access 9.7, question number 2 and 9. So it will be on page 213. I think that's it for today. We stop here. I'll see you soon. Bye-bye.